So this is some simple Python software cooked up here at University of Florida, and the software runs Sparkle query files and then emails out a report showing what the results were. And the Git repo is right here at github.com/nrejack/dchecker. And I'll show you the structure of the application here. It's one main Python file, and it reads in a very short configuration file that tells you where to email the queries. And then vivotools.py are some functions developed by Mike Conlon that run Sparkle queries and help us out with other kind of Vivo tasks. And then the queries directory are all your queries. And it's designed so you can just drop a query file into the directory and the program will read it, so you can expand it without having to modify any of the program code. So you see right here, I've used a naming convention because the report reads in the name of the query file. So it strips out the underscores, and then you'll see the number of results for each next to the query name. So let's just open up one of these. These queries are designed specifically for UF just to keep tabs on things that could be a problem for us. So this is one that checks to ensure that we're not placing people inside the UF police department. So that would be a bad thing, at least for, for VIVO public display. So it runs the query, comes back with the actual number. And all the queries are designed so a good result is 0, and anything other than 0, that's a problem. So we don't want to get any non-zero results. So I'll show you how it's run. We have this cron to run every morning at 2 a.m. and then email the results to our internal VIVO list. But I'll just run it in the debug mode, and all that does is it will email the results back to me. Okay, so the results will start coming back. It'll start building a list here for the report. We see that ACS is home department for person. That came right out of this first query right here that it read in, and as we would expect, it's a 0, so that's good. ACS organization for position, and I wrote the queries to check each direction of the links for these, so you really have to look at the query to understand what it's querying. And then when we get a non-zero result, we have to modify the query to bring back the actual URIs that are problematic. In future versions...
What do you mean by each direction? What do you mean by each direction?
Okay, so we can go from the person to the position, but we can also look at the link going from the position to the person. So we check both directions. So UFPD as home department for person, and then the other direction is person with home department of UFPD.
Why is it necessary to check both?
We could have triple statements hanging around there in VIVO that if for some reason the reasoner didn't add both directions or it's old bad data, we could just have one of the directions for one of these statements that usually the reasoner adds the other direction for us automatically.
So if you only had the query written for one direction, you might miss the other one and still leave the triple in there, right?
That's right, yeah.
So how long does this usually take to run?
It takes about 5 to 7 minutes. Some of the queries are a little faster than others. Right now it's probably running the authorship's not linked to authors query, so that might take a little while because we have a huge amount of authorships.
So can you show us some of the other queries? Like show us that query, so how is that written?
Yeah, so we grab all of our authorships, and then any of them that don't have a linked author, then we count those up.
So could anybody, is that a query that might be a good example for people to run in any VIVO?
Yeah, there are a couple of queries in here that are UF specific queries and things like that. Those will work on any VIVO that has publications.
And in that case, you're checking to make sure that a publication has an author?
Well, specifically, the authorship is linked to an author. There is a query that will check if the publication is linked to an authorship. So we have that kind of three-step process for linking things up. Here's another query that's pretty generic that'll work in any VIVO. So we look at all our positions, and then we check to make sure that all those positions are linked to organizations. This is actually even a little more generic. It just checks to make sure the position is linked to something. So depending on how you've defined ranges and domains in your local ontology, you can add different queries to be more specific, or it's really up to you what you want to do with the queries. I'd be interested to see what people add on. So we've seen a few more results come back. No duplicated dev IDs, no duplicated gator links, which are our local identifiers. Also, UFIDs are another local UF identifier.
And Nicholas, do these just run in sequence without, you don't have to do any timing, they just run in succession? Does the query wait for one to complete before it fires off another one, or do you just
Yeah, they run sequentially. There's the code is over here actually. They run one at a time, and there's a timeout set in the VIVO tools that runs the query. So if you're not getting back the results right away, you'll see it'll say, query did not come back, waiting 2 seconds. Back on whether it's working or not.
Okay.
But yeah, it just iterates over everything in the directory one at a time.
Uh-huh. And by not bringing back the URIs and just bringing back the count, it means that it's less work for the query. So as long as the count is 0, you don't need to go in to look what's going on, but you do have to if you find that you've got a count greater than 0.
Yes, we'll see when the report finally comes back in a minute or two. What we want to see is just a nice, pretty column of zeros, and that means that we don't have any work to do. But when we get back non-zero, that means we have to dig around a little deeper.
I think you mentioned last week that you found that this has been very helpful for detecting when one of your ingest processes is somehow injecting malformed data, so that you're sort of nipping it in the bud, in effect. Right?
That's right. Since it runs daily, we can see the changes from day to day. Sometimes we'll do merge operations on patched authorship or something of that nature. So we can track it back looking at our log file that we have from the previous day saying, oh, we worked on these people and their URIs were affected and their authorships were somehow broken.
So the motivation, right, was that we were worried that data would sneak in that would be bad, and it would take us a while to find it, and that would just become more of a problem over time as it accumulated, and so we wanted to catch it early and catch it often.
When we initially ran, we had counts, like 80 duplicated UFIDs. That's quite a lot. So cleaning it up, we're seeing more on the order of you might get 1 or 2 over the course of a week, and that it's much easier to figure out where those came from and figure out why the data is like that.
So what does your query for duplicates look like?
So I group the UFIDs and then count the number of URIs associated with that, and then filter out any that are, well, I filter out any that are only 1. since the UFID should be unique to each person, if we end up having a URI with, or if we end up having a UFID that is associated with more than one URI, then that's a sign. We have to go fix that.
Right.
Okay, so it's finished, and I'll jump over to my email, and this is what it would look like. So we do have one thing that needs to be fixed. Otherwise, it looks good. And some of the other improvements I'd like to make this would be to add a kind of logging functionality, maybe expand the options for configuring it, and then of course it'd be pretty cool if we could read in the affected URIs at the end of the report.
Right, to sort of go back and have another query ready that would do the more details.
Right, I thought a little bit about how to develop that, because I would need to probably develop just a parallel set of queries that would, instead of doing the counts, give back the URIs. So I might have to have a folder which is just count queries, and then have a folder which is URI queries, and make sure that both files are named the same thing so the program can figure out which query to run.
Uh-huh.
So, but for the most part, people could take this code, copy your queries, and if they wanted to write a new one, they could copy an existing one, change it a little bit, drop it in the folder, and that's all they'd have to do, and it would be included in the next run of the report, right?
Right. They'll need to make sure to point it at their Sparkle endpoint. So you would do that in the VIVO Tools software. All the way at the end here, there's a function that runs the query against the UF endpoint. So you would point this at your own.
And you could probably wire, if you don't have a separate Sparkle endpoint, you could probably use curl or something to get it to run against, to log into VIVO and run it against the Sparkle query. The Sparkle query servlet in VIVO.
That sounds good. I've never tried that.
Here at Cornell, we've had a somewhat similar, we've had sometimes to remove a lot of data, and there's been debates about whether the strategy is better to try to remove everything, including all the potential connections. Like if you remove a person, do you go and remove all their authorships and their positions, and then if they were the sole author of that publication, do you try to spider that out and remove that publication, or and I think we've concluded that it's better to do a sort of a contained approach like this, where you recognize that you may not have deleted, you might have left some orphans behind, but to have the queries already written to go find the orphans so that you take care of the problem, but you don't try to make an extremely complex deletion query.
A lot of these that we find you can fix, because if you have a publication where you have 5 authors and one of the authors is broken, it's pretty simple to figure out which one is missing. But other ones where the authorship is not linked to a publication, there's nothing you can do with that, so you just have to delete it.
Yeah. But there's always things like date-time intervals that are left flying around, and sometimes it's easiest just to go after them separately, but you have to remember to do that. This looks pretty useful, Nicholas. Thank you for demonstrating that.
Yes, you're welcome.
It's also neat to see some Python code examples of interacting with VIVO data. That was pretty neat. So thank you for sharing that.
Definitely.
Well, I think that's about it for Nicholas's presentation. So we'll have this posted so people can watch, and the code will be at github/nrejack/dchecker, right?
That's right.
And of course, Nicholas can be reached at nrejack@ufl.edu.
Mm-hmm.